So this is a presentation on the Overton window and how we've taken some of those concepts and applied them to our usage of infrastructure as code. Before we get started, do a little bit of an introduction. I'm Ben Somogyi. I'm a senior staff DevSecOps engineer. I work for Lockheed Martin. When I'm not working, I fit the standard Colorado template. I'm in the mountains. But you can also look me up. I'm part of the end user tab with the CNCF. So happy to hear anyone as end users reach out through that organization.
Yep. And I'm Alec Lewis. I'm also a DevSecOps engineer at Lockheed here in Colorado. Also fit the standard Colorado template for things I like to do. But I've worked as a performance flight test engineer, a software ground system, a satellite software ground system test engineer, and now as a DevSecOps engineer with Lockheed through my career.
So there's a couple big problems that we have faced within Lockheed Martin as we've been trying to implement infrastructure as code and platforms as a service concepts. One of them, and these problems you may face as well, but with our organization where we have programs that are 50 years old that are legacy software programs, and some that are cutting edge pursuits that deal with dangerous sensitive fields and are sometimes very adverse to perceived or actual risk. It causes a big variety of problems with what software do you use and what's acceptable when you're implementing that platform. So how do you adapt to change and these varying customer requirements? The sheer number of products that are available through the open source community is amazing, but it's also overwhelming. So, how do you deal with that constant change? How do you know what products to use? And how do you make sure that you're still meeting the needs of your customers with the products that you've chosen? And then another problem we face is we're a very big company, so there's a lot of NRE expense that happens. So every new program that gets started, there's development effort that happens at the startup to be able to start building whatever was requested or on contract for. So how do you start to standardize infrastructure as code within your organization to stop that reinvention of the wheel? The product that we build within Lockheed Martin and the framework that we've established is enabling us to kind of make the platform reusable in this space where you have 100 plus programs that are all doing something slightly different, and the solution we build to support them needs to meet that need. So identifying those problems is half the battle. So a little short detour in some politics here. I know it's an exciting topic, but the Overton window, how many have heard of the Overton window? Okay, so for those that are not familiar, it's really how politicians sometimes determine, what's acceptable within their electorate. So, they don't want to jeopardize their chances of getting elected by, siding with some policy that's considered, not good or, not acceptable with their electorate. So this window can also shift. So, there might be some policy that is considered radical at some point in time, but as it's discussed and groups advocate for it, that window shifts and starts to become more acceptable. So those policies then can be put into law and be considered acceptable to that electorate. So this is important to understand. It helps organizations shape whatever they're building or what policies they're establishing based on what the public opinion agrees is acceptable. So why do we care? At the keynote, I know Google is browsing the CNCF landscape in their leisure, but there's a lot in this landscape, and this is just the CNCF's landscape of products. So how do you know when you look at this, like what's acceptable, what products should you use? So how do you navigate this tension between innovation and identifying open source tools that are acceptable to use for you, your customer, or within your organization. So the answer is the Overton window, or the Overton window concept. So, looking at the products within that landscape or outside that landscape and determining what is acceptable to your organization. So how do you identify this window? In the picture on the right is the Overton window. So tools that maybe are not being maintained or have a specific license that maybe can't be leveraged within your organization. Maybe there's a subscription associated with that product, or it's got a monolithic architecture and they're manually testing it. Those might be characteristics that are undesirable, and those products would be shifted out of your window. But products that have MIT licenses or well-known like Apache 2.0 licenses, maybe they're publishing containers and they're automating their testing and they have good maintenance around that product. Those would be the characteristics that you associate with a product that would be within your window and considered as acceptable. How many are familiar with the HashiCorp license change that happened about a year ago? So if you're not familiar, HashiCorp basically transitioned from the MPL 2.0 license to a business use license. And that caused a little bit of uncertainty within the open source community. So much so that Linux Foundation actually forked Terraform and created the project OpenTofu. So if you look on the right, that actually caused within Lockheed Martin some concern of what's the future of this product Terraform and within the open source community itself, to the point where some organizations chose to use OpenTofu instead of Terraform because they didn't know what was going to happen with it in the future. So this is a kind of a trivial case. It was a fork, so same functionality. You were able to just pretty much pivot to OpenTofu. But consider what happens when products shift out of your Overton window that are more detrimental and harder to refactor to use. So what happens if the Kubernetes distribution you're leveraging is no longer acceptable and shifts out of your window? Have you architected your system to be able to support that change? The window can also shift. On the right is an example of the different layers of development environments. So maybe in the past it was acceptable for development teams to just subscribe and get a managed development environment from AWS, like say EKS. But maybe your company has shifted from, we don't want to pay for subscription or automation of our environments, and we want our teams to be able to self-serve those development environments. So maybe a tool like Crossplane is now, which maybe was considered more radical, is now within your window because it's starting to shift as the perception changes of tools they're newer, that enable better technology or better solutions to supporting that use case. So your infrastructure as code and how you develop it needs to support these types of shifts, whether it's products moving in and out of your window or your window itself shifting. So some strategies for dealing with this change. You really need to move away from rigid infrastructure tooling and practices that don't scale or allow for change. So one thing we've done within the platform we've started to develop is make sure it's very modular. Modularity is key. Being able to plug and play different tools is paramount. Make sure you're leveraging infrastructure as code in a way that supports the sensible and popular choices within your organization, so those that are within your window, but make sure that it supports those radical or more unthinkable tools or products that may eventually be part of your window as they start to, as people's opinions start to shift. So, Crossplane being one of those. So some strategies on standardization. So establish patterns for collaboration and reusability with the software you're using. So, within Lockheed, we have a lot of silo development efforts. So how do you eliminate those silos? Start to think about establishing SIGs within your organization that talk about best practices, bring those teams that are doing the same things together, start to collaborate. And then enable modularity and composability through standard interfaces. So, make sure you establish best practices for deploying infrastructure and design that support the inevitable when those shifting Overton windows change. I'm going to now turn it over to Alec, who's going to talk a little bit more about our solution within Lockheed.
Cool. Thanks, Ben. So as Ben kind of alluded to, we really wanted to focus on designing with changing the system in mind. A lot of declarative code is one way, it's rigid. You write a whole bunch of custom Terraform code, you deploy it, it works great for that exact solution. But we wanted to start building in modularity into these things because we do have so many different diverse customers that every single one of them has a different set of requirements. So we're looking to incorporate secure supply chain. It's becoming a huge button issue, really bringing cloud native even to those older programs that might be really set in their ways for doing things, and start to iterate faster on delivering these kinds of systems just by building in the flexibility that we know exists by taking a holistic view of ourselves as a company. So this framework enables groups, developer groups, to start to handle those shifts in the CNCF landscape and establish patterns more than an actual set solution to be able to adapt to their Overton window for their specific customer. On the flip side, we want this community to be able to contribute back. So end goal, of course, is doing that all the way up to open source, but a lot of times contractual reasons or internal IP that might not be completely possible. But you want to build that community even inside your own company with the idea of inner source, so just open source inside the company. And if you can get people talking in the same language, at least from a kind of process point of view, you can get them comfortable with sharing things even across team boundaries where in the past they might not have been able to do that. Really importantly, because we have so many diverse customers, we look to deploy in multiple different cloud environments. We want to be vendor agnostic because one group could say, yeah, let's deploy RKE2, and the next one says, no, I don't want to use that vendor for some specific reason, and we have to be able to handle that. So having this shared framework that's really more of a process and guidelines around how you can contribute and the best practices to make these things modular has really helped us accelerate meeting all these different customer needs. And we've really seen a lot of the from scratch development start to tick down in our company because of it. So a really key point here is the specific solution is not as important as a pattern and teaching your developers how they can work and share in this kind of world. So to kind of go over tenets of the architecture that we're putting forth in the company, it's got to be stable. As Ben said, we're working with highly sensitive areas. If you're writing code that's supporting human spaceflight, that code has to work 24/7, 365, or someone's life could be on the line. So stability is absolutely paramount, and reliability is paramount as well. So really leverage all the great work in open source and cloud native to bring that to as many infrastructure providers as possible to meet where your customer is working. And you want to be building in layers to monitor that system from the ground up. It shouldn't be an afterthought. You really got to know what's happening in the system throughout the entire lifecycle process. Vendor neutrality, I've hit on a little bit, but that's also super key for flexibility because people are willing to pay lots of money for some things, or you'll have a project which has to run really light and lean and everything's got to be free and open source. So building that in from the ground helps tremendously. Reusability, modularity, switching things out is key. I've said it probably 4 times already, and then of course ease of use. If it's not automated and it's not easy to use, no one's going to pick it up. So the approach we took, it's nothing really that novel, but it's really taking core infrastructure as code tools and creating standardized interface in our company that make it easy for users to bring those in and out as they need. So in this specific example, we're using Ansible to do API calls to spin up VMs, configure them, save off that golden copy. That image is a solid interface that you can pass on to your infrastructure provider and use Terraform to spin those out as VMs, a Kubernetes cluster in this instance, which is running more modules in Cloud Init to join into Kubernetes clusters, and then you can come over the top and configure it again with Ansible for any explicit configurations after the fact. But by the same token, if you need to change some of those things out, having the ability and the abstraction away from writing specific Terraform code by pulling in those modules, you can easily swap it out for OpenTofu. You can add another custom layer running Ansible code to do cyber scanning, stigging, all those things that might be required from your customer. And as we look a little deeper, this is all built around modules. So Ansible has been really great about pushing Ansible collections recently. It's a great way to share reusable code through Ansible as a wider community, but you can also use it inside your company. So in this example, we've just got a requirements.yaml file that's pulling in a bunch of custom in-house collections that we're using to deploy all these things. So you can define them up front. And in this one, we've got kubeadm, so we're doing a custom Kubernetes distribution. But if you write a module for RK2, it's got similar input-output. You can drop it in, and now you have the ability to use either in this system. As you can see in this example, we've got a little bit of Jinja templating in there, and we're just using that Python front-end layer to do some security credentialing, so you're not spilling secrets as you're connecting to these internal endpoints, and we're also doing just a little bit of configuration management. We apply the same to infrastructure. We're using Terraform modules, all hosted on an internal nexus where you can stub out your different cloud providers and make sure you have feature parity across them so you can deliver to where your customers are working. That modularity all the way down is where we've really found the success. You can switch at the cloud provider level. You've got Ansible code that's cloud agnostic to run to do your Kubernetes configuration during Cloud Init, as an example, but then the entire infrastructure provider is configurable by swapping it in and out with another one. As long as you get those right inputs of here's how I declaratively define which provider to use, the system should be able to handle it. And then walking through that first example again, we've got another Ansible layer that's going to come over the top and configure Istio and our Argo CD UI for our custom DNS. It's not in these particular slides, but we're also using GitOps for as many things as we possibly can, and creating a shared GitOps library in the same kind of methodology that we've shown for all these others has been super useful. And one of the other things we want to focus on from the ground up is secure supply chain. So that's been something that's super important for our customer base, and we've really started to build all these pieces in from the ground up and trying to find ways that the secure supply chain requirements that are being levied on us by our customers can actually work for us instead. So in all of our GitLab pipelines, we're generating SBOMs from the very beginning. We're gathering a whole bunch of different sources for package management, pulling everything in, getting a giant bill of materials that has everything we possibly need to transfer to an air-gapped environment. We're generating CVE reports, and then we're attesting and signing those packages for traceability. So you've got that really nice thread from beginning to end of provenance and attestation. From there, we're using an open source tool. It's really an ecosystem called Hopper. It's a Lockheed Martin open source tool that takes SBOMs as your source of truth, bundles it into a tar bundle that you can then transfer over to your air-gapped network, and the code tool dropper will expand that back out to your target endpoints. So really designing with air gap in mind, being able to push things back out to endpoints and deliver it to where the customer needs it. So what benefits have we really seen deploying a platform like this? We've seen a huge cultural shift in the company and in our customer base towards increased collaboration. Really having those conversations internally, making sure the teams know that it's okay to contribute back to open source or even share between team to team in a company has been huge for reducing our cycle time and our costs for delivering. And we've built huge internal user bases that are coming up with novel ideas, and they all have a framework to talk and share with each other without having to reinvent the wheel every time. It's also a huge reduced learning curve. So if you, we've deployed this on 50 plus programs in the company, and you can have users coming from one program to another very quickly. They've already learned how to use it, and it also removes a lot of that base level infrastructure as code that you need to get in place before you can start developing applications. And this is just kind of looking at it another way for the more management and cost-minded people. Our NRE was brought down significantly because it's just a huge amount of reusable work just by designing with understanding that a little bit of change is acceptable and something you need to watch out for. All right. I think that's all we had, so are there any questions?
There was one slide ago you said this was a shared platform.
Yep.
But it also seemed like the way you guys were describing it was that you provide code to your customers and they kind of deploy whatever they needed. Is that a correct statement?
It is a little of both. Traditionally, we are providing it to a program team inside Lockheed that's going to use it to develop a solution to then deliver to the customer. But that reusable code is part of the delivery where they can then spin it out in a customer air gap environment. So it's part of the solution, but it's not something that we are explicitly selling as a company. It's just an internal tool that we give on projects.
Yeah. So when I say customers, I mean your customers being the teams within Lockheed that would be.
Yep.
But platform, I think, is more something that you guys build and maintain, and the engineering teams on board onto your platform. So it sounds like that's not the case with your platform?
It's a little bit more of an abstraction of we have a recommendation of a platform, but we don't set solid guidelines that says you must use RKE2 as a Kubernetes distribution. We say, hey, here's some easy code to do it, but here's a framework that if you want to replace it with K0S, great. Share that within the company because there's another external customer to Lockheed that might have a requirement that says, I can't use that for any specific reason.
One last question. I think when it comes to engineering centralized systems like this, the most difficult thing is getting the engineering teams to change their engineering practices to onboard with whatever you want. That often involves huge programs like tracking adoption rates and all kinds of metrics. And for me, that is the biggest problem when it comes to like this type of platform engineering. What are you guys doing in that space, and like how did you solve those problems?
I think the biggest thing we've done is we've kind of established an inner source community within the company that has really grown. It was kind of a very small effort that this project started with, and this framework that we started establishing that grew, and people started to see the benefit within the company, and that got more and more traction to the point where we have a pretty big community now that's all collaborating on this same framework and way of deploying these platforms. That's just benefited us immensely. I don't know if that answered your question or not.
So many more.
You're more than welcome to find us after, or we can hang out. Okay. Yeah.
Do you have any specific example or episode where you actually, maybe in your development or review something where you actually make code more agnostic, where you're doing this and then you did something else to actually make it more reusable and not coding any specific purpose?
Yeah, I mean, I think, that's one of our core tenets is really to build an agnostic framework. So, understanding the diverse requirements that we get from all the different contracts that Lockheed Martin works, that has to be in the front of our mind. So, you know, everything we build is how can we make this work so you're not vendor locking. That's just a huge piece of the architecture to make sure that we're not doing that. We have built several solutions that helped us avoid vendor lock or from using certain services that would have locked us in. But yeah, I mean, that's just a tenet that we've had with developing this system.
Yeah, we had a unique perspective and ability to come in to other programs rather than being on that contract from the beginning and help them go from a very locked-in solution and say, hey, you know, if you start thinking about this in a little bit of a more system mindset, and yeah, you can definitely write something to get to do logging or pick some Kubernetes tool to do logging, but as soon as you want to try to sell this to someone else, that might have to change. So really think about solid interfaces between those components and ways that you might share it within your company. So like Ansible collections being one of the examples. Instead of just writing a bunch of Ansible roles, we keep it in like a central Git repo. We publish collections that are all tested, signed, attested on their own, so that you could pick it up, you could use it completely without using the framework we're developing, or you can click it into the framework and it'll work as expected.
Any other questions? Cool. Well, thanks for spending some time with us. Find us afterwards if you have anything that comes up that you would like to talk to us about.